Bueno, ¿cómo están? Bienvenidos al WarehousingLab, a la sesiones de entrevistas que hemos venido llevando a cabo desde el año pasado sobre diferentes temas de operaciones, de logística. Y en esta oportunidad vamos a conversar sobre un tema muy interesante que tiene que ver con la industria 4.0. En esta sesión de entrevistas vamos a tener como invitado al profesor Lukas Merkel. Lukas, profesor de Alemania, nos ha acompañado varias veces, tanto en el pregrado como en el posgrado, enseñándonos de qué se trata la industria 4.0, los retos, las características, pero sobre todo, qué debe tener la pequeña y mediana empresa para poder llegar a estos, llamémoslo así, retos o hitos de empezar a desarrollar proyectos de industria 4.0. También nos acompaña nuestra monitora Valentina Ramírez y me presento. Siempre me quedo de último presentándome. Juan Gregorio Arrieta, soy profesor del Departamento de Ingeniería de Producción, miembro del Grupo de Investigación en Gestión de la Producción y Logística y del Warehousing Lab. La entrevista va a ser en inglés. Vamos a hacerle las preguntas a Lucas en inglés, él responde en inglés, no tendremos traducción. Y primero que todo, presento excusas ante todos los posibles errores en pronunciación, en todo que pueda tener. Entonces, empecemos. Lucas, thank you very much to join us in this interview from the Warehousing Lab at EAFIT University and the Production Engineering Department. Thank you very much. Let's begin with Lucas. Tell us a little bit about yourself. What are you doing? Your academic background, some information about you and your work.
Okay. So first of all, I would like to thank you, Valentin and Juan, for giving me this opportunity to have this interview with you to talk about Industry 4.0. And I really like our cooperation. I think it began in 2017 when you visited us the first time in Augsburg, Germany. And we did some courses at the Universidad EAFIT in 2018. And yeah, we had some groups here in Augsburg last year, and I'm happy that we can continue this cooperation with this interview. So my name is Lukas Merkel. I'm a mechanical engineer, and I have been studying at the Technical University of Munich until 2015. After that, I've been working as a research associate at the German Fraunhofer Association for about 4 years. And now I'm about to finish my PhD on cognitive assistance systems at the Technical University of Munich. And 2 years ago, almost 2 years ago, one of my colleagues, former colleagues, Johannes and me, we started our own company. It has the name APT, and we developed our own product, the Smart Learning Factory, which is a lab for digital transformation, a lab for Industry 4.0, and our business is to develop this lab, to implement it in different locations, and also implement different or do different software integrations on Industry 4.0. And our main expertise is in the field of mass customization. So lots of variants, customer-specific products, and using IT to help companies produce products with a high variety with the same costs as mass production. So this is our field of expertise.
Okay, Lucas, thank you. Okay, first question. Lucas, in a few words, a very simple word, simple as easy words, how do you define Industry 4.0? Taking in account that our main objective is single and medium enterprises. And for that reason, what is, in your words, Industry 4.0?
So for me personally, Industry 4.0 is all about making data-driven decisions. So you acquire a lot of data in your factory, it's processed, and a machine, a computer can make a decision based on data, or the data is provided to a human, and the human is making better decisions made on current data, analyzed data from the production side. So for me personally, Industry 4.0 is all about making data-driven decisions in a manufacturing system.
Okay. Do you consider Industry 4.0 just technology, robotic arms, automation, this kind of technology, or companies need to take into account additional factors like organizational behavior, culture, etc.? It's not just technology, or is just technology? According to the objective of this interview is for small and medium companies.
So in my opinion, it's not just technology, and technology is an enabler, and technology can enable something. So, so it can enable something, and this can be a new business opportunity. For example, I was talking about mass customization, customer-specific products. So, technology can enable a new business model. Of course, it can also help to increase productivity or quality, but technology is getting really interesting when it can enable new businesses. But on the other side, of course, you cannot just implement any kind of technology. You also have, let's say, lots of requirements. Those requirements can be in HR, it can be the acceptance of the employees. There can be employees who are afraid of working with digital tools. So maybe when they are asked to use their smartphone or a tablet in a production site, they are afraid of destroying something. They are used to working with a pencil and a paper, and they are afraid of destroying something. But then there are other generations, maybe young people who use a smartphone every day in their daily life. Maybe they are more open to new technologies. So, but age is not the only factor. There are different criteria, different factors that influence the acceptance of digital technologies. So the acceptance is very important, but you also have other requirements like a strong internet connection and so on. So still here in Germany, when I'm in the train, I often don't have any internet on my phone. So we're a very high developed country, I would say. But when I take the train from Augsburg to Munich, which is the third largest and largest city in Bavaria, when I take the train from Augsburg to Munich, there are let's say 30 to 40% of the time I don't have internet on my phone. So there are also a lot of external factors that are important to use Industry 4.0.
Okay. Lucas, according with this previous question and your answer, we have another one. How does a single and medium enterprise could reach Industry 4.0 elements in order to reach this development? What do they need to develop this kind of projects in technology or in structure or in knowledge? Talking about a company that has only the people, the machinery, but is not involved with the technology, and they want to develop those ideas or those projects. What would you tell about that?
Yeah, that's a very good question. So in Germany, there are a lot of large companies, and they have some kind of innovation budget. So they have a few million euros which they can spend on innovation. But usually, small and medium-sized enterprises don't have an innovation budget where they can play around. So it's harder for them to get in touch. So I think You have to think about where can they get access to those new ideas. So, and I think this can be some kind of a software partner, an integration partner they work with, who knows all about the newest technologies, because they will later also need someone to implement it. So it could be a software integration partner. It could be some kind of showcases from Industry 4.0 software and hardware providers. So those showcases, they could be presented online on YouTube in a video, on a company's webpage, on a fair, some showcases. But on the other side, they can also be real world showcases, maybe in other manufacturing companies. So industry associations could help to create an exchange of ideas. So for example, here in Bavaria, we have different industry associations where they have different circles where, for example, production managers meet in the production manager circle, and then the production managers from different factories meet and they exchange their ideas. And maybe they do the meeting in one manufacturing company and then they do the next meeting 2 months later at another site. And so they can see each other's plans and to exchange their ideas. I think this only works when the companies are not in direct competition, because you don't want to see your you don't want to let your direct competitor inside the factory. But if they are not direct competitors, but from the same industry, then maybe an exchange of ideas, a production manager circle, and an industry association would be interesting. But also universities, innovation labs can help. In Germany, there's an initiative funded by the German government from the Federal Ministry of the Economy. There's an initiative called the SME competence centers. So all over Germany, there are around 15, or I don't know, let's say 20 competence centers for SMEs. And those competence centers are operated by universities, by research organizations like Fraunhofer. And in those competence centers, they show applications. They do some kind of Industry 4.0 scans, quick checks, where they go into companies and support them with and develop a technology roadmap for them. And also do like networking events, e-learnings. So this is an initiative from the German government, the SME competence centers, where they especially target SMEs because they often have more difficulties to get in touch with new ideas.
Okay, look, no, very, very interesting your answer, because you said we have to use our clusters, looking for our suppliers, our customers, in order to get integrated, in order to improve.
Mhm.
And in this improvement, what is the impact that you know about implementing Industry 4.0 in the companies? What is the impact that is implementation could cause in our companies?
Yeah. Okay, when you talk about the impact of Industry 4.0, I think you have to separate two completely different settings. So one is Industry 4.0 in your product, and the other thing is Industry 4.0 in your production, in your manufacturing side. So if you develop, if you're a company who makes a machinery equipment, for example, or if you're a software company, then Industry 4.0 can be really interesting for your product. So if you're developing machines, then you have to make sure that your machines are Industry 4.0 ready, that they have the right sensors, the right interfaces, where you can get the data from. If you make cars, it's not Industry 4.0, but you might want to produce cars that are open for car-to-car communication. if you make, I don't know if motorcycles, if there's like a communication from motorcycle to motorcycle, I don't know, but or if you're an equipment manufacturer, sensor manufacturer, your strategy should be how to make your product Industry 4.0 ready. And if you're a software company, you should think about how to implement the right interfaces, the best user interface in your product. So this is the side Industry 4.0 in your product. And the other topic is Industry 4.0 in your production side. So of course, you can implement Industry 4.0 technologies in your production side to increase productivity, quality, to create new business models. So I think it's not only, I think productivity shouldn't always be the main focus. You can introduce improved productivity with digital tools, but digital transformation Industry 4.0 can offer so much more. They can give you better data to really analyze your production and you can do so much more with your data than just increasing productivity.
Okay, that is perfect. Lucas, another important question that everybody is asking that.
Yes.
Do you consider that Industry 4.0 is replacing manual labor or replacing handwork? What's your opinion about that? And if this is going to happen, could be, what can we do with our collaborators, with our workers, in order to get skills to apply it or to know or to work with Industry 4.0? But first of all, is this technology is replacing people?
So in Germany, 30 years ago, there was let's say a hot topic in the field of production engineering, and it was called CIM, computer integrated manufacturing. And the idea of computer integrated manufacturing was to create a so-called dark factory. That means you don't need any workers, you have fully automated systems, and you can turn off the light. So that's why the name is called Dark Factory. And so this concept didn't work out, and because the information technology, the IT, wasn't ready for it. Today, of course, IT is way more advanced than 30 years ago, but people also learned that a dark factory isn't the main goal. So of course there are already dark factories. For example, in processing industries, you don't have any workers. So you have this already since 20 years ago. But if you talk about manual processes like manual assembly, final assembly, those processes are very hard to automate, and digitization should be so. Digitization is one thing, and automation is another thing. And there are a lot of digital tools like assistant systems who have a high level of digitization, but the goal is not to get rid of manual labor, but the goal is to improve manual labor and get rid of all administrative tasks, looking for documents, documentation tasks, so that the manual labor has a very high productivity. And I think there will always be manual assembly processes, especially for small lot sizes, for high variants, for low numbers. But of course, the economy is transforming, and I think so 50 years ago or even longer, let's say in the Middle Ages, so when you were grown up, you learn a job and then you do this job until you retire. And I think you cannot fully transfer or fully bring this concept to the 21st century. So you always have to learn new things. Maybe you have to learn a second or a third job. You cannot do the same thing what you did after graduation for the next 40 years every day. That's not possible to be successful in the 21st century. And I think you have to advance, but I think it's a good. You ask what to do with the people who are replaced. There will be people who are replaced, and what to do with them. And an easy answer could be, of course, education, training. Of course, they have to learn a new job, but 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 you cannot take all manual workers who just lost their job and say, okay, you are becoming IT experts and you're writing software now. So this is not possible. So if you just say training education, this answer is too easy, and not everyone is able to become an IT expert and become a programmer. So, and I think how to bring the people to the right job where they can really do something which is in their skills level. I think this is one of the toughest decisions or toughest problems of this century. So I don't have an easy answer for that.
Oh, Lucas, it was very clear, and
Mm.
you answered most of the last questions,
Okay.
because in your company is Smart Learning Factory. That's one of
Mhm.
your products. You develop training courses in
Mhm.
your facilities.
Okay.
You are doing consulting with your colleague Johannes.
Mhm.
The last question is, what do you recommend or what do you suggest
Mhm.
to universities or colleges,
Mhm.
or even though schools, in
Mhm.
order to get in touch or get involved, the companies obviously get involved in this topic? What are the skills that university, the school, etc., need to be developed in order to get in touch with this
Mhm.
relative new knowledge in
Okay.
to be applicable in the
Mhm.
companies, manufacturing companies, services companies, in all the areas? What do you suggest?
Okay. I think at first you need a solid basis of a basic knowledge, and then you need to somehow specialize. So when I'm talking about the solid basis, I'm talking about engineering and computer science. So if you
Uh-huh.
want to become an expert in Industry 4.0, you need to know the basics about production engineering. You need to know which manufacturing processes are there, how they are categorized, what's the difference between mass production and production in batches, and what are the typical ways to organize a factory, manufacturing technologies, of course. Also, you should have some basic understanding of typical engineering topics like materials, physics, everything. So you need a solid foundation in production engineering. On the other side, you also need a solid foundation about IT, about programming, about coding. So you should be able to write your own little program, to have experience in different programming languages. I don't know, like Java, Python. You should be able to see the difference between different programming languages and also have written lines of code on your own. So then you have a basic understanding about IT, about programming, about engineering, and then you're able to bring this together. And then I think you should, a student or also a university should some kind of specialize in different topics, because When you specialize in something, you become an expert in something, and then later someone with a specific problem will come to you because you're the expert for this problem. So nobody will come to you because you know all the basics about engineering, all the basics about programming. That's not something that's something you need to start with. But then you need some kind of area of expertise where you focus on. So, and this could be so many topics. So this could be tracking and tracing in logistics. This could be using artificial intelligence in quality control. This could be AGVs. It could be robotics. It could be anything. So, but I think it would be a good way to specialize in some kind of topics. So if you say I'm the expert for Industry 4.0 and I can do everything in Industry 4.0, it will take you a lot of time to reach this level. But if you say, okay, we know about Industry 4.0, but our expertise is in tracking and tracing of logistics, of material supply in the automotive industry, then this is a very specialized topic, and then you can really help companies in this industry to solve problems in this field. So you need a solid foundation in engineering and computer science as a student, and I think every university is offering this. But then you need some kind of specialization, a topic. Maybe where as a student you write your master thesis, you write your master thesis or your bachelor's thesis, or maybe university has some kind of a lab or some kind of industrial partners they cooperate with, where they work with, so they know real problems from the industry.
Okay. Lukas, that's the end of the interview. Thank you very much to join us, to join the Warehousing Lab, and to express to our audience, to our single and medium companies, these useful and little clues or tips in order to get involved on this new knowledge. We hope we continue talking, presenting your smart learning factory and your projects, anything. Thank you a lot. We have in touch. We keep in touch. In next opportunity, say hi to Johannes.
Okay, I will.
Okay. Bye bye. I'm
Okay.
going to change to Spanish in this moment.
Okay. Thank you, Valentina. Thank you, Juan. And talk to you soon. Thank you.
Okay. Bye bye. Adiós.
Bye bye. Adiós.
Entonces, hasta aquí llega nuestra entrevista del día de hoy sobre Industria 4.0. Miremos la importancia de todo lo que nos decía Lucas con relación a la aplicación. Ya Valentina nos dirá el acceso y todas las otras, digámoslo así, características que tendría la entrevista, dónde la podemos consultar, etcétera. Y para esta sesión de entrevistas del Warehousing Lab, muy importante su participación. Estamos iniciando los ciclos de entrevistas y los vamos a seguir invitando a nuevas presentaciones. Y muchas gracias por estar con nosotros en el día de hoy. Valentina, muchas gracias a vos también.